Excellent.
Yes.
Okay, so I'd like to talk about the importance of agent-based modeling for official statistics. Um, and to start off with, I should mention that I'm really impressed by all the results from the biological and medical applications that I've seen. So my own talk will probably be slightly disappointing in the sense that we're only just starting on the road of using biodynamo. So I don't really have a great deal of results to show. But I do want to discuss with you where we want to head and activate the community and perhaps help me out here and there when I need it. So official statistics, well, probably people that know a little bit about official statistics know uh, um, that official statistics agencies like ourselves, Statistics Netherlands, or the ONS in the UK, or the Status in Germany, their core business is to present many types of data, tables with all sorts of economic or sociologically interesting or relevant facts and numbers. So modeling doesn't really appear as something that statistical agencies classically do. And there is actually some discussion, even within the Netherlands, whether we should do any kind of modeling at all as a statistical agency producing official statistics. And one of the classical arguments that I quite often hear, that I want to note briefly, is that official statistics does not use models. That's some of my older colleagues tend to say that to me. And this is, of course, absolute nonsense, because every estimator, after all, we are doing statistics, and every estimator implicitly presupposes a statistical model by which you determine your margins, your expectations values, and everything else. So that argument is simply invalid. And also, especially within the Netherlands, there are some issues with doing predictions in time. And it is true that in the Netherlands, there are some agencies that are created specifically for government to calculate scenarios and do that kind of forward planning, the so-called planning bureaus. In other countries, it's quite often the domain of ministries themselves to do this. So that is true, but of course, in order to do scenarios, do modeling of the future, you need a model, and ideally you need a model that is actually quality certified, that is calibrated to, at least in the recent past, produce something that is actually valid, that produces something that looked reasonable. And if you do not do that, then your models are worthless, and therefore your future scenarios are worthless. And there, of course, the data to actually calibrate and validate models, that's not the domain of the planning bureaus, that is the official statistics institutes that have that data and can therefore do those calibrations properly. But that does require, of course, that you are aware of how those models work. And then, of course, you can always ask the question, well, the models that are currently used, are they good enough, or should we also work on improving models, for instance, using agent-based models to improve the scenario testing that we see at the moment? Because quite often the models that those planning bureaus or ministries use are quite simplistic. Okay, so well, why in particular agent-based models? There are other ways of trying to model and do scenarios. Well, characteristic for economy and society is that you have individual agents, a population, and yes, people are particular interests for us, but also a population of companies, enterprises, that each has an individual existence, but there are also interactions. Just as between people, there are interactions, between companies, there are interactions as well. And it's not always exactly the same way that you would want to treat either, but in both cases, it's agents that you want to work on. Now, the Netherlands, it's not geographically a very large country, but in terms of population, it's quite densely populated country on the whole. So there are about 17.5 million inhabitants in the Netherlands. So really, when we want to look at the trends in society, and we have lots of data and we monitor all sorts of trends as a statistical agency, each of those trends is really the collective effect of the individual interaction. So it's emergent behavior of that system, and it's too simplistic to simply model this in terms of a handful of groups, the migrants and the non-migrants, or the higher educated and the lower educated, and there you go. That's a far too simplistic way of treating treating society. So you really would want to monitor social structures in much greater detail and study things like segregation, integration, polarization in society in much more detail by going much deeper into the individual interactions on which this is based. And one of the reasons why this is so important is that if you model this at a mesoscopic level, so just take some subgroups and model those as being homogeneous, that really ignores that just about every subgroup that you can think of, within it, there are very skewed distributions of all the other characteristics that you can think of. So migrants, for instance, come in all sorts of levels of education. The wealthy or poor come in all sorts of levels of education, and vice versa. So there is the fact that those distributions are not normal distributions, but very skewed quite often, means that treating that as a homogeneous group simply leads you astray. So it's not good. Okay, so the kinds of things that with my background I think of when I think of agent-based models is really the analogy with the large-scale simulations that are done to simulate, for instance, the large-scale structure of the universe. My background is in astrophysics, and I worked for quite a while in the kinds of systems where structure forms, and that was also what I was thinking about when I was asking just before the break about dynamical ranges. Because, of course, when you think about large-scale structure in the universe, then the dynamical range of the density in the universe is enormous, and you would need to adjust your grid according to the structures that you see forming. Now, in the case of, for instance, the distribution of wealth in the Netherlands, there too, there's actually a quite large range in terms of the relative wealth of individuals within the country. So if you want to study the effects, for instance, of education on accumulated wealth over a lifetime, then you would really want to be able to follow very large dynamical range kinds of situations like this simulation of large-scale structure and star formation and galaxy formation shows. Now, the difference between this kind of simulation, I'll stop it because it's distracting a little bit. The difference between this kind of simulation, which is really a fairly simple one, the individual blobs of gas interact through gravity, so it's a very simple interaction rule in principle. Of course, with people interacting, we kind of have to start from scratch, because individual interactions between persons, people are very complex beings by themselves that have lots of ways in which they can react to each other. So we need to include the knowledge that has been gathered about the rational or irrational behaviors of people and the types of behaviors that people with different characteristics, different types of education, income, migrant background, but also life course events that they have on the way that people interact. So that is likely to lead to even richer behavior than we already see in simulations of of this type. So that's the kind of thing that I want to pursue. And in fact, what it comes down to when we want to do the modeling is really understand whether the kinds of interactions that we can think of, whether those produce emergent behaviors that we can understand. So really build up from very, very low level to even understand whether the things that we think work on a microscopic level, individual interactions, whether those produce the kinds of results that we actually see in terms of trends. So setting up appropriate interaction rules is by itself a challenge that we need to meet, and that we're going to work closely with departments of sociology in the Netherlands and in other countries. And of course, that's not the beginning. That's only the beginning, because once we have the simulations running, we need to also develop the appropriate analysis tools to be able to get from our artificial data, our synthetic data, the agent-based model simulations, tools to allow us to compare that with what we can actually measure in real society. Now, there's very many problems that, of course, you can tackle with this. One of the particular things that is very relevant for statistics lens, because there's a lot of news coverage of that in recent years, and also there's international attention to it through the Sustainable Development Goals, is inequality. Inequality in society can take very many forms, but one of the ways that you can think of is the inequality in income, which is relatively modest in a country like the Netherlands, or inequalities in wealth, which are actually rather larger in the Netherlands. So we really would want to investigate the kinds of mechanisms that produce the kinds of inequalities that we see. So once again, if you were to start with completely equal society and set it going, does that then approach the actual income distributions and wealth distributions that we can see, that we can measure in the Netherlands, and under what circumstances does it do so? Another thing that you can think of is whether the process of renewal and deterioration of neighborhoods in cities, whether that behaves like a kind of reaction diffusion system where repeatedly various communities, as they age, change in composition, change in social status, deteriorate, and perhaps when a new population moves in, that it goes through the entire process again. So that's the kind of thing that we would want to understand in order to, for instance, help with urban planning, or with planning in circumstances that the climate changes substantially and the sea level rises, which would be a major issue for a country like the Netherlands. Okay, in the somewhat longer term, what I envisage is that rather than producing synthetic data, we produce a simulation tool that is calibrated on what we know of the Dutch population in recent years, and offer that as a service to allow them to run realistic simulations with realistic, true distribution functions for all of the kinds of properties that Statistics Netherlands has in its data storage, demographic details, income details, etc., so that it allows a much wider range of research to be done with a powerful tool that really allows for the entire population of the Netherlands to be run. And by the standards of the people present here, 17.5 million is only a medium scale, easily tackled problem. And of course, in the longer term, perhaps if it turns out to work, then I'm sure that other countries, other EU countries, would be equally interested in having such a tool at their disposal for all of the big problems that countries face, and all of the policy aims as formalized in the Sustainable Development Goals, for instance, would require a good scenario testing for. So that's really what I wanted to talk to you about today. So it's more an outlook and plans than real results, unfortunately. Thank you for your attention.
Thanks very much, Frank. That was very interesting, and yeah, I'm always again astonished how relevant agent-based modeling is to so many different topics. I mean, we've just seen it today, right? From cancer research to neural development to socio-economic simulations and proteins and so on. So that's really interesting. Who has questions?
I have a question, if I may.
Yes, absolutely.
And I have been working with Frank on this, so I could have asked the question earlier, but still, if I look to the discussions today, and thanks for organizing this, Roman, I was really reflecting. I think from a biology perspective, it seems we pretty well know how to describe interaction between cells in somewhat of a mathematical way, which I can envision. But I think most of us in this audience have no background on sociology. At least I think that would surprise me if the majority has that background. Frank, could you give us a little bit of feel how sociologists define interaction between people in a mathematical way that can be sort of a basis to define how that works in an agent-based model? Because for me, that feels a challenge, almost a project by itself. But maybe you can give us some
It's
hint on
certainly
that.
a very big challenge, Han. I agree. Thank you for the question. And actually, there is a community of a branch of sociology called computational social sciences. It's relatively recent, but there's now a community building, certainly in the Netherlands, but I think internationally as well, that really tries to quantify the kinds of ways in which people would interact in sociological senses. So in the sense that if people with rather different incomes come into contact with each other, what that tends to do to the way that they interact socially, what it tends to do with the way that financially there could be an exchange. So there's quite a lot of work being done. Also in terms of smaller scale, what you might call social lab experiments. How willing are people to part with a little bit of money to get a return that they think is larger? That kind of interaction can be expressed in terms of probabilities. Mm-hmm. Probably you're aware of Kahneman, a quite well-known researcher in this field, who has done a lot of work in trying to quantify how people react to particular situations. So that's the kind of thing that you could encode in the kinds of agent-based models that we have.
That's good to hear. So there is specific niches in the science area that is already doing this, that we can build on.
Yes.
Thank you.
Yeah.